Alright, today we're going to be taking notes on section 2-3, solving multi-step equations. And this is very similar to what we did yesterday, except for now we're going to have more than one operation whenever we're solving these equations. Alright, so here we go with example 1. First of all, I want to review our order of operations. I've got them located over here on the right. And the first thing that we always do whenever we're completing a problem is we see if we have parentheses, then exponents, then multiplication or division from left to right, and then addition or subtraction from left to right. Well, whenever we are solving equations, we are working backwards. So what that means is we need to move up on our order of operations. So that means the first thing we're going to get rid of is any addition or subtraction. So right here we see that we've got a -4. So we're going to do the inverse of that, which is add 4. And remember right here we've got our two sides of the equal sign. So I'm going to add 4 over to the left side, and I'm going to add 4 over to the right side. So right here I've got -4 plus 4. That's going to give me 0, which cancels out. And then I'm left with, on that left side, 11x. And then on the right side, what I'm going to do is 29 plus 4, and that gives us 33. So now what I have here is 11x equals 33. So I've got another step that I need to do, and I need to get rid of that 11 that's with the x. The 11 is being multiplied with the x, so we need to do the inverse operation of that, which is divide by 11. 11 divided by 11 gives us 1, which is the number that we want in front of the x. And then 33 divided by 11 gives us 3. And so as we remember from yesterday, we always can check our answers to make sure they are right. So our original problem was 11x minus 4 equals 29. So I'm going to substitute that 3 for the x, so that gives me 11 times 3 minus 4 equals 29. That gives us 11 times 3 gives us 33, and then 33 minus 4 is 29. So this does check out. It is the correct answer. So x does equal 3. All right, now example 2. This one is a little bit different. Okay, notice that we've got a division bar right there, and the division bar is underneath everything on the left side. So what I want you to do is I want you to go ahead and add over here on the order of operations, step 5, division bar. So that means that is the first thing that we need to get rid of because we're working upward on the order of operations. So right here, to get rid of that divide by 8, we need to do the inverse of that, which is multiply both sides by 8. Multiply the left side and multiply the right side by 8. So these are going to cancel out right here, and it gives us 1. And then that leaves us with a plus 7. Sorry, I'm having such difficulty with my pen right now. Okay, let me rewrite that. That gives us a plus 7. And then on the right side, that gives us 40. All right, so now I've got a simple one-step equation right here. So I'm trying to get the a by itself, so we need to get rid of that plus 7. To get rid of the plus 7, we subtract 7. 7 minus 7, that gives us 0, so those cancel out. We're left with a equals, and then 40 minus 7 gives us 33. So now we are going to check to make sure that that 33 is the correct answer. So I've got a plus 7 divided by 8 equals 5. That's the original problem. I'm going to substitute that value in, 33 where the a was. 33 plus 7 divided by 8. We're going to see, does that equal 5? And 33 plus 7, that gives us 40. And 40 divided by 8 does equal 5, so it does check out. So this a equals 33 is the correct answer. All right, example 3. Okay, so like I said, we've got two sides of the equation right there. We've got the left side and the right side. We're trying to get the variable all by itself. We're going to work our way up the order of operations. So that means the first thing we need to get rid of is any addition or subtraction. So right here I see I've got a minus 8. So I need to get rid of that by adding 8. Okay, those are going to cancel out because a negative 8 plus 8 gives us 0. Now we bring down the 3 halves, a equals, and 11 plus 8 gives us 19. Now if you remember from the previous day, to get rid of the 3 halves that's being multiplied with the a, we need to do the inverse. And the inverse of that is multiplying by the reciprocal. And the reciprocal of 3 halves is 2/3. And we need to do that to both sides. So 2/3 times 3 halves gives us 6/6, which will simplify to 1, which is the number in front of the a, which you don't need to write. All right, and then over here on the right side, we're going to do 19. And actually, if you want to, you can put that 19 over 1. And then we just multiply straight across. 19 times 2 gives us 38. And then 1 times 3 gives us 3. And if you could simplify that, you would. But we are not able to simplify 38 divided by 3. And it's you could change it to a mixed number, but we're just going to leave it here as an improper fraction. And so then our last step is to check this. So once again, we had 3 halves, a, minus 8 equals 11. So I'm going to substitute that 38 over 3 where the a is. Minus 8, and we're going to see if it equals 11. So right here with our multiplying the fractions, we see that we can cross simplify the 3's. When you divide those by 3, you get 1. And then the 2 and the 38, we can simplify those by dividing by 2. 2 divided by 2 gives us 1, and 38 divided by 2 gives us 19. And then when you multiply straight across, that gives us 19 over 1, which is 19. And then 19 minus 8 equals 11. And it does, because 19 minus 8 is 11. So this does check out. And our solution really is a equals 38 over 3. Alright, now example 4. We have the sum of 3 consecutive integers is 51. Okay, so right here, this word consecutive might be something a little bit new to some of y'all. Consecutive means one right after another. So for those of y'all that play sports, you know that if you have 3 consecutive games that you've won, that means you have won 3 in a row. Or, you know, we could have 5 consecutive losses. Okay, so consecutive just means one right after the other. So we are looking for integers that are one right after each other. So that could be like 1, 2, 3, because those are one right after another. It could be 21, 22, 23. These are all consecutive integers. Okay, so whenever we're writing our equation with that, we don't know what the first integer is. So we're going to put n. We're going to choose the variable n to use for that. That's the first integer. Then the next one would be 1 right after that. Well, 1 right after n is n plus 1. And then the 1 right after that would be n plus 2. Okay, so right here I've got the first integer, the second integer, and then the third integer. And notice that our word here is sum, so that's why I've put pluses in between those integers. Then right here we've got is, so we know that that means equals, and then it equals 51. Alright, so now I've set up our equation. The next thing we need to do is solve it. So the first thing we're going to do is get rid of these parentheses and just combine our like terms. If I've got n plus n plus n, that gives me 3n. And then 1 plus 2, that gives me 3. Equals, and then bring down the 51. So now we're solving a simple two-step equation. First thing I need to get rid of is the plus 3, so I subtract 3 on both sides. Those are going to cancel out. That gives me 3n equals, and 51 minus 3 gives us 48. Divide both sides by 3 because that 3 is being multiplied. Those cancel out, which gives us 1n, and n equals 48 divided by 3 gives us 16. So that means that our 3 integers would be 16, 17, and 18. And then to double check to make sure that's correct, all you would do is add those 3 integers up, and they should equal 51. All right, now our example 5. This one is very similar to the last one, except for now we've got 3 consecutive odd integers. So that would be, for example, 1, 3, and 5. Or it could be 11, 13, 15. Or another example of that would be 27, 29, and 31. Okay, so that means that odd integers, notice they are 2 away from each other. And the same is still true if it was even. Even integers are 2 away from each other, as odd integers are 2 away from each other. So that means whenever we write our equation, the first integer is going to be n. let's try that over again. The first integer is going to be n. The second integer is going to be n plus 2. Having a difficult time here with my pen. So we've got n. It doesn't like me writing these n's. And then n plus 2. Okay, I got that n right. That would be the second integer. And then the third integer is another 2 away, so that'd be n plus 4. And we're going to set that equal to, because there's our is, set that equal to 141. Alright, the next thing that we're going to do is we're going to combine our like terms on the left side. So right here I've got n plus n plus n. That's going to give me 3n. And then the 2 plus 4, that gives us 6. And we set that equal to the 141. All right, now we've got a simple two-step equation. The first thing we want to do is get rid of that plus 6 by subtracting 6. That gives us 3n equals, and this is going to give us 135. And then we divide by 3, and that gives us n equals, that should be 45. Okay, so that means our first integer is 45. So then the next one would be 47 because we're just looking for the odd. And then after that would be 49. And then you could add all three of those numbers up and it should equal 141.